Hello. In the world of deep learning, we are well aware that if we use a pre-trained model and then fine-tune it, that is a better approach than training a model from scratch. This approach is called transfer learning, and the benefits are that we would need less training time during fine-tuning. It saves us some computational cost, and also we wouldn't need a lot of labeled data when we're fine-tuning. In the last video, we learned about the T5 model, which is a pre-trained transformer model that we could use to fine-tune for any other NLP tasks, such as translation, classification, summarization, and so forth and so on. This all works great until we want to build stuff in languages other than English. So that's where mT5 model comes into play. And M stands for multilingual, and T5 is the same model structure that we learned in the last video. So let's take a closer look at the mT5 model. mT5 is a pre-trained model that is available on Hugging Face by Google Research, and the model is described in this paper called a massively multilingual pre-trained text-to-text transformer. Now, it's beneficial that you have already read the T5 paper. I also have a video about T5 on my channel, so I encourage you to watch that first because I'll be referencing the T5 model as we review this mT5 model. In short, mT5 is a multilingual pre-trained model that is trained on 101 languages. So if we recall, the T5 model is also a pre-trained model, but it was trained only on English text. At the core, both this T5 and mT5 are transformer models, so you have a full encoder and a decoder architecture. So let's take a closer look at this mT5. We recall from the T5 paper, it states that every NLP problem can be formulated as a text-to-text problem, meaning we are not training the model to do individual tasks such as classification, translation. We are training the model to take in some text and output some text. And the way they do that is by attaching a task prefix. So for example, if you want the model to summarize a document, you would attach a prefix called summarize and then give it the input document. And we want the model to give us out the summarized. So here they state that there are other multilingual pre-trained models such as MBERT, MBART that exists today. So this mT5 falls into the same category of models. I'm going to skip over the T5s and C4 because we discussed that in the previous video. So now let's take a look at this MC4 dataset. And this is the dataset that is used to pre-train this mT5 model. This dataset is basically scrapped from the web, and they use this CLD3 to detect the language in the text. And after they do all of that filtering, we get dataset that contains 101 languages, and this is the dataset that is used to pre-train this mT5 model. As far as the training of the mT5 model and its architecture goes, it is same as the T5 model. So at the core, it's the transformer model, and they use the same techniques for training the model, such as the denoising objective, how they formulate the problem. So all of those are the same as the T5 model. However, one of the key things when we are dealing with this multilingual pre-training is the question, how do we sample the data for different languages to make sure that we have balanced data for high resource languages and the low resource languages? So if we recall, the high resource languages are like English, for which we have plenty of data available on the web, and low resource languages are such as my language Punjabi, for which we do not have enough training data available. Let's take an example. So let's say we have 1,000 samples available to us for the English language, and we have only 100 samples available to us from Punjabi language. So when I'm preparing my training data, I decide to use all of those 100 samples from the Punjabi language, but I decide to use only 500 of the 1,000 available from the English language. So in the hindsight, what I'm trying to do is I'm trying to make sure my data is not heavily focusing on the high resource language. So that's why I decided to use all of my Punjabi samples, but only part of my English samples. If we try to sample data that way, that can result in the model overfitting for the low resource language, but underfitting for the high resource language. And one way to avoid that is to sample data from high resource and low resource languages through some proportional measures. So the approach that they take is here. So they say the probability of sampling data from some language is proportional to the number of examples or samples that exist for that language to the power some number, which they call alpha, and this alpha is a hyperparameter that can be varied. And they do some experiments for different values of alpha, and they settle on, I believe, using a 0.7. So this is how they make sure that their data that they're using to pre-train is somewhat balanced, such that it does not overfit for low resource language or underfit for high resource languages. All right, so I am not going to go through the mT5 model itself because at the core it is again a transformer model, and the way it is trained is described in the previous video when we discussed the T5 model. So now let's take a look at some of the results from this pre-trained model. So here we are using this mT5 model, which is again pre-trained on many languages from MC4 dataset. Specifically, it is pre-trained on 101 languages. So we use that pre-trained model, and then they fine-tune that model. The results that we are seeing here is after we have fine-tuned that model, and these are the results on various tasks. There are three categories. The first one is called cross-lingual zero-shot transfer. So here they take the pre-trained multilingual mT5 and then they fine-tune it with only English dataset. And then they are trying to do the prediction in other languages. So that's what we mean by cross-lingual zero-shot transfer. And these are the results that are available, and these are the different versions of the mT5 model. Then the second category that they have is translate train. So here again we start with the pre-trained multilingual mT5 model, and then it is fine-tuned with English dataset plus the translation of that English dataset into other languages, 101 languages. And then these are the results that are obtained. Finally, the third category is where again they start with the pre-trained mT5 model, but during the fine-tuning this time, they use the actual data in the languages. So not the translated data, but the actual text in other languages to fine-tune. So these are the three categories that they tested with. And in all of these, we see that the XXL model is the one that gives us the better performance. So again, but the larger models give us better performances, which we all know by now, because that's where the large and large language model comes from. Next, let's see what else we have. So experiments we just mentioned, and we also saw the results. Taking a look at this figure first. So here what they're showing is when we have small models, then the difference in performance in the three categories that we saw before is stark. But as the model size increases, the difference in performance converges. Basically, here we see that when we have small models, the training with the actual data in other languages gives us the best performance as opposed to using fine-tuning with English only dataset or fine-tuning with English plus the translated dataset. However, as the size of the model increases, we can see that if you fine-tune with just English only dataset, which is the zero shot, you get similar performance as fine-tuning with the English plus the translated dataset, and the performance with the actual dataset from the other languages is still higher, but the difference is quite small. So that means, as they say here, these trends point to the possibility of avoiding the costly step of annotating data in more than one language when using large models. So when you are using large models, if you just fine-tune with one language, in this case it was done with English, you are able to get similar performance as you would if you had enough data for other languages. Now, the next thing that they point out here is when you have massively multilingual pre-trained model like the one we have here, they tend to underperform on a given language compared to, let's say, a model that is more specialized and trained on a specific language. So they do some experiments here comparing the performance of mT5 with T5. So again, the T5 model is specifically trained on English, so we expect it to behave better on English than the mT5, which is a pre-trained model that is multilingual. And that's what they're trying to show here. So when the models are small, as we see here, then the specialized model such as T5 performs better on the English tasks compared to this multilingual version. However, as the model size increases, both of them, the one that is specialized on English and one that is multilingual, they tend to have similar performance. Let's take a quick look at this section called zero shot generation. One of the abnormal behaviors that authors have seen with models that are pre-trained with multilingual data is during the zero shot generation. So again, this is where you fine tune a model with a certain language and you are predicting for other languages. What they have observed is the model sometimes does wrong predictions, which they call illegal predictions. So if you take a closer look at what those are, so those are three kinds as categorized in the paper. So here the first one is where the where the prediction does not exactly align with the target. So as if we take this example, here the target is supposed to be 12 and then the superscript A, but the prediction is 12 and the A is just not a superscript. This is one type of wrong prediction. The second type is where they have grammatical errors, as they show in these two languages with Arabic and Russian. The third type is where they have accidental translations. So here the target is in some language, but the model, instead of predicting the text in the other language, it's predicting the text in the English language. And interestingly, it is predicting the translation of that text in the English language. So it's almost like model forgot the other language that it had seen during the pre-training. The solution that authors provide to this accidental translation is mentioned in the section here. So basically, they say that when you are fine-tuning the model, rather than fine-tuning it with one language, you also include small amount of multi-language data. So similar to how this model was trained on 101 languages, you would fine-tune with majority, let's say the English language, plus you would include small amount of the data from those 101 languages. So as they say here, you only need to include small amount, and in this case they just experimented with using 100 times more English data, but just one part of that multilingual data, which you have 101 languages. So by doing that, in the fine-tuning stage, you are including other languages as well, which it had seen during the pre-training phase. So that's how they prevented or actually lowered the accidental translations. So that's all for this paper. So to conclude, we discussed the mT5 model, which is multilingual pre-trained model that is pre-trained on 101 languages. And we also saw how to prevent the illegal translations that sometimes these pre-trained multilingual models can show. That's all for today's video, and I hope that this was valuable. And again, to remind, one of the reasons we are reviewing this T5 and MT5 model is because eventually we are going to learn about the IA 101 model, which we will jump in the next video. So I hope to see you there. If you like the content on this channel, please consider subscribing, and I would love to have you on my channel. Thank you. Bye.